In the last section, we started investigating the life cycle of a container by using the docker create and docker start commands. We're now going to start to investigate the status of some of those containers that we've already started up on our machine, but have closed down for some particular reason. So we can print those all out with docker ps -- all. You'll notice that I have just one container listed as exited now, whereas before I had like 30. The reason for that is that I ran a command between the last video and this one to kind of par down that list. And of course, I will show you that command in just a second as well. So at this point, the only stopped or exited container that I have on my machine is this one right here. Let's try creating and running and then stopping one more container just to make sure that we're kind of on level footing. So I'm going to execute docker run busybox echo hi there. If I then do docker ps -- all again, and then zoom out so I can see this a little bit better, there we go. I'll see the ID of that container. I'll see the echo hi there, and I can definitely verify that its status is definitely exited right now. When a container is exited, we can still start it back up. So just because a container stopped doesn't mean that it's like dead or cannot be used again. We can very easily stop and then start containers again at some point in the future. To start a container back up, we can take its ID and then execute docker start and paste that ID in. Remember that if we use docker start without the -a flag, however, we won't see any output from it. And so it might be a little bit more useful to do docker start -a and then the ID. And when I do that, you'll notice that it printed out hi there again, which is kind of interesting. Let's take a look at a diagram to really understand this entire series of commands that we just issued. All right, here we go. So we've got our busybox image, and at some point in time, we definitely ran docker create or docker run. That took our file system snapshot and essentially got a reference to it inside the container. We then provided that override command of echo hi there. So that was the primary running command inside the container. That command ran, it then completed, the container exited naturally. When we then ran the docker start command a second time, what happened was the running process, or this primary command, was issued a second time inside the container. When you have a container that's already been created, we cannot replace that default command. As soon as you start it up with the default command, that's it. The default command is then in place. So we cannot do something like, say, docker start -a, the ID, and then try to replace the default command. I can't do something like echo by there. So in theory, this would be us trying to replace the default command. Again, can't do that. And if we try to run it, it's going to misinterpret the command that we just issued. It's thinking that we're trying to start up multiple containers at the same time. So once we have started up a container and let it exit, we can start it back up again, which is going to reissue the default command that was used when the container was first created. All right, now it might seem like going over all this lifecycle stuff is kind of unimportant. It might seem like I'm going really far into the weeds with it, but trust me, having a solid understanding of the life cycle of a container is going to be so incredibly useful later on when it really comes down to figuring out how to troubleshoot these things and debug a running container. So I think we got a better idea on the life cycle of a container. So let's take another quick break and continue in the next section.